So we're going to be given a graph of a polynomial, and we need to identify what factored form would represent the polynomial. So all we need to do in these problems is think about the fact that these roots, these x-intercepts, came from a factor that was opposite of the number. So x plus 3, if it was set equal to 0, would have produced a negative 3. And then we have negative 8 and positive 8. Well, down below, you're going to see some squareds, and squareds give me two roots, a plus and minus of the same value. So we have plus and minus 8. So if that's equal to x, if those are my two solutions, I got positive and negative 8. If you just go up a level and figure out where those came from, we would square both sides. So raise both sides to the second power, and you would get x squared equals 64. And that will help us decipher which of these factors is the right one, because if I set it equal to 0 and go back to this layer, my x plus 3, the factor was x plus 3 equals 0. I need to bring the 64 to the other side by subtracting it. So if I say x squared minus 64 equaled 0, I would be able to have the factor that produced these two roots of 8 and negative 8. So down below, I'm looking for an x plus 3 and not an x squared minus 6 plus 16. Jeez. That's not what I meant to say. So down below, I'm looking for an x plus 3 and an x squared minus 64, which is this first one. If you had an x squared plus a 64, that would have given me imaginary solutions. So the other thing we're going to be watching for today are factors that produce imaginaries, which will happen if we have a cubic that's only touching the x-axis one time. So I picked this problem because it goes through the origin, and that throws people off. Whenever it goes through the origin, you should immediately run to an x factor. So we only have two choices that have x's, and then now we're looking at the fact that we have 7 and negative 7. So that's got to come from an x minus 49 to get a plus and minus 7. Now again, this x right here, this is x equals 0. That's a factor of x, and I get x minus 7 would have produced that 7, and x plus 7 would have produced this 7. Putting it all together, you get x times x squared minus 49. So this time we got 3 different roots. Now notice I can't actually see what that is. That's not quite negative 5. It does hit here at negative 1, but then it hits somewhere between 4 and 5. So it's kind of like, I don't know what my factors are. So now I'm just going to be sorting through my options. Well, what happened was I did indeed get a negative 1, which came from x plus 1. So first thing I want to do is get rid of the x minus 1s. That's just there to throw me off. The other one, it's trying to tell me the 22 is what I'm playing with. Now, to get a plus and a minus, I can't have an x squared plus 22. If I try to do x squared plus 22, that would have resulted, if I set it equal to 0, I would get an x squared equals a negative 22, and that would not produce actual x-intercepts. It would have produced imaginary solutions. So I'm definitely going to be picking the minus 22. So even before I work it out, I know that this is my answer here. But now what this is this is going to give me two values. This is the positive square root of 22, and this is the negative square root of 22. Because what happens is I have x squared minus 22. If I set that equal to 0, I get x squared equals 22. And I would square root both sides. And when I square root, I get a plus and minus answer. So I have two solutions, a positive square root of 22 and a negative square root of 22. I don't have to know exactly where those are. I just have to know that it had to be that scenario to match up with this answer choice below. So if you ever have two solutions and it's coming out of a square, you have two of them, it's not the plus. The plus would not produce two solutions. It produces, or two actual solutions on the graph. It's two imaginary solutions. And now we have our first example where we have a cubic polynomial that is only touching the x-axis one time. It is touching at negative 6, which means we're definitely going to have a factor of x plus 6. And then we don't have any more factors. So I have to look down below at my answer choices. The answer choices have x squared minus 4 and x squared plus 4s along with the x plus 6. So these answers are gone. It's these two I'm focusing on. So it's either the plus 4 or the minus 4. Well, if I had an x squared minus 4, this would produce a factor of x minus 2 and x plus 2, which would have produced 2 more roots. That's not what I'm looking for. This bottom corner answer is the one I'm looking for, where if I had set those each equal to 0, I get x plus 6 equal to 0, and that produces my root 0 equals my root over here of negative 6, and then I get my x squared plus 4, set that equal to 0, and I would get x squared equals negative 4, and if I solve by the square root method, I would get a plus or minus 2i, and that does not show up on the graph. Those are complex solutions, and it looks, anytime you have a graph that's looking like this, these curves that are above the x-axis are coming from complex solutions. They don't actually touch the x-axis, but to satisfy the fact that if I have a third degree polynomial, I should have 3 solutions. So this is 1 solution, and then my other 2 solutions for a total of 3 complex solutions. Here we have our second example of a polynomial that is only touching 1 time. That is definitely a third degree polynomial because I have 2 terms. So this is a cubic function that's only touching 1 time, which means that I have 2 imaginary solutions in addition to my solution of 3. So first thing I want to do is say this is x minus 3's factor, resulting in a root of positive 3. So I get rid of the positive 3 options. And again, that's because if I set this equal to 0 and solve, that produces x equals 3, not negative 3. And then the other solutions have to come from a quadratic that is being added to a value that if I solve by the square root method, x squared plus 1 equal to 0, I would get x squared equals negative 1, which is going to produce 2 imaginary complex solutions. So it's plus or minus I. So that will satisfy the fact that I have 1 real solution and then 2 imaginary solutions. So I'm looking for an x minus 3 times x squared plus 1. And then now this x squared plus 1, I'm just using my multiple choice options there. I would have no idea what my polynomial is right now without a much more complicated process by just looking at 1 root. So we're taking advantage of our multiple choice and just recognizing that if I have x squared plus, that means I have only the 1 solution of the 1 real factor present. Now we're going to look at graphs that have even multiplicity. So anytime we have a graph that touches the x-axis, but it's bouncing off, anytime we got some BO, some bounce off, it's a multiplicity that's even. So what that means is this root, x equals 7, shows up twice. And then the wider the thing goes, the higher degree it has. But this one's going to be a 2. We're just going to be calling this a cubic function. This is a x minus 7 scenario, and it's got to be there squared because this is multiplicity of 2. In other words, that root shows up twice in order for us to bounce off. Even multiplicity bounces off. Odd multiplicity passes through. So this negative 1 came from an x plus 1 that shows up once. Its degree is 1, whereas the x minus 7 has a degree of 2, which causes a multiplicity of 2 in the root of bounce off. So now I look down below at my multiple choice options, and what I'm looking for is x plus 1 once and then x minus 7 twice. So that would be this answer down in the right-hand corner to be my multiple choice option that satisfies this graph. Another opportunity for multiplicity to appear on our graph, we have multiplicity that's even on this root at negative 8 because it's bouncing off, which means that this negative 8 came from x plus 8, has to be a degree of 2 to get that bounce off. Now it came up and bounced down, and then we come back through this negative 5, which means we have x plus 5 as our other factor, and putting those together will produce that polynomial that we're looking at right in front of us. And so we're looking down here to multiple choice options, which is going to have x plus 5 once and x plus 8 twice. If you have a factor showing up twice, it's even multiplicity. That's going to produce the bounce off we see over here at -8. Now in this graph, we have two roots that both have multiplicity. So this -6 came from a factor of x plus 6, and it bounces off, which means that this factor has to have a degree of 2 or 4 or whatever. It's such a nice term there. It's probably 2. And over here, we have x minus 4 would have produced that positive 4. Remember, it's always opposite of the sign for the root. If I set that equal to 0, I would have got the positive 4. And then we have a degree of 2 there to make that bounce off. So anytime it's bouncing off, you have a degree of 2. And down below, we're just looking for this factor, and we're looking for them to both be squared. So it's x plus 6 squared, x minus 4 squared, which is this multiple choice option down below, deciphering 4 between our 4 choices. And again, technically you could have a similar graph if it was to the 4th or higher power, but we could utilize our choices below to know that it's squared. And if it was a 4th, it'd be a wider turn through there. But anyway, at least it's even degree and it satisfies our choices down below.